Hey everyone, thanks for joining us today. Today we'll be talking about inverters and tips for helping owner-operators live comfortably and operate your inverter. Use all the comforts that you'd like in your truck without damaging your batteries or causing any other heartache. So I am, quick introduction, I'm Hall Fess, sales director here at Purkeys. And I have on here with me Larry Rambo, who is one of our senior SAEs, been with Purkeys for over 30 years now. I'll go ahead and kick us off and then turn it over to Larry here in a minute. So to start off, just cover the basics, start very high level. What is an inverter? An inverter, just to define kind of what we're talking about today, is just any machine that converts DC power to AC power. We're looking to provide a 110 power output here in the States. In Europe, it might be 220. But for purposes of our conversation today, we're just talking DC to AC, 12 volt to 110. But most of these principles we're going to be talking about can be carried over to other power levels as well, if that's something you're working with. In the main purpose of this, specifically in the trucking industry, and the things we'll be hitting on today are providing power to run creature comforts in the cab, TVs, microwaves, hot plates, whatever that might be. But again, depending on kind of what you're running, a lot of what we're going to be talking about today as far as how to calculate how much power you need, how to look and read these outputs and things like that can be carried to pretty much any electronic. So when you're choosing an inverter, what are some of the things that you should be looking for? There are a lot of different aspects to inverters. There are a lot of different pieces that you'll see on marketing from different companies. There are a few things that we want to focus on today that are kind of key elements that you want to look at to decide which way to go and kind of what are the pros and cons for each of these things. Again, kind of keeping it fairly high level. We'll get into detail a little bit later on a few features. Oops, went too far. So first thing is there are inverters and there are inverter chargers. So the main thing to look at here, this is kind of the first question to answer. What exactly do you want your inverter to do? Do you want your inverter just to power some sort of electronics? Do you just need it to run the TV and that's it? You just need 110 output. Okay, you just need an inverter. However, if you say have a lot of different loads and you know you're going to be drawing quite a bit of power, and you know, hey, every night I'm going to be parked at this type of truck stop or this type of location, or a lot of nights I'll have access to shore power, then you may want to look at an inverter charger. And just to be really clear on what those differences are, an inverter charger still does the same things as an inverter, but it also has the capability of charging the vehicle's batteries, but it has to be connected to shore power with that. So that's kind of the key thing here. We've run into a lot of fleets, a lot of drivers who want an inverter charger. They get it from the factory, and that's great. But you know, the question we always ask is, are you able to actually use the charging portion of that inverter charger? When are you able to be near shore power? Make sure that the rest of your truck is compatible with that shore power, because a lot of drivers are not typically in the area to use that, and so you're essentially just paying for an added function that you don't need. So a few of the pros and cons here. Pros of an inverter charger: you can charge your truck batteries. That's a fantastic thing to be able to do if you're able. You can reduce idle time through doing that by letting your truck batteries last longer, so your truck doesn't have to kick on. And you can increase battery life by just keeping your batteries at a generally higher state of charge. However, there are some cons to this. Like we were saying, charger is an added feature. So generally, these are more expensive. The chargers can be different sizes, from 10 amp chargers all the way up to 80 or 100 plus amps, depending on what inverter it is. So you want to make sure you're looking at that, and that'll obviously impact the cost. Install is a little more complex. We've got a wiring diagram we're going to show next to show exactly why and kind of what that looks like. And of course, the third piece that we've touched on a few times, you got to have access to shore power, right? You've got a charger on there. You got to plug into shore power to use that charger. So you want to make sure if you're getting this, that you make sure to access the power necessary to run this thing. So when you're installing this, like we said, the wiring is a little bit more complex. It's not anything that's too crazy. The main difference, as you can see here, is that there is this shore power connection. This cable that's running to the plug down here in the bottom left of that diagram. So as you can see here, both of these inverters, we have the power going to the batteries. We have a fuse pictured there. We'll talk more about fuse and circuit protection specifically a little later on. Your negative is still just going to go to the negative on the battery, ground on the battery. And then you have the outlet. Sometimes the outlet is mounted on the inverter. Sometimes it's mounted separately, but either way, that's where that power outlet's going to go. The main difference here is you want to make sure that your truck is wired for accepting shore power if you have an inverter charger. Again, this isn't particularly complex. Purkeys, as well as other companies, sell a kit to allow you to do this. Most factory inverters, if not all, I believe, have an inverter charger option and come with this setup. So it's not like it's a anomaly in the industry or would be particularly complex, but you just want to make sure that you have that and understand before you're buying an inverter charger at wherever you're buying it from, that you will need to account for that different wiring. A second key feature of inverters and inverter chargers that you want to think about when you're buying these at the beginning is a modified sine wave inverter versus a pure sine wave inverter. All this really means is, just like you can see here on the actual sine waves on this diagram, is the way that the power gets put out from the inverter to your device is slightly different. So pure sine wave is essentially what you're getting from a wall outlet in your home or hotel or any kind of building that you're in. And this just means that you've got a pure, smooth power output that's going to your inverter and to your electronics. A modified sine wave, which was the industry standard for years, that standard has recently started to switch to pure sine, and that's kind of, I'll get to that in a second, but modified sine wave, just like you can see here on the graph, it's a bit of a step function. So all that means is when the power is coming from the wall, it's going to be a little bit choppier. It's not going to be quite as smooth in that curve as you might get at home. Now, for the most part, on a lot of things, this doesn't really impact function of electronics, but more and more these days, as electronics get more sensitive, as things get more advanced, you're seeing more and more appliances or TVs or whatever that is sensitive to this type of output. So to go into a little more detail, with modified sine wave inverters, again, you can power most electronics. They're not as efficient as a pure sine inverter because you don't have that smooth output. It's kind of choppy, so you lose some power along the way, which typically means that you might need to size it up a little bit bigger than you would for a pure sine inverter. And you can create more heat. And again, the reason it does that is with the output not being as smooth, it just has to work a little harder to create the output, hence leading to the inefficiency, which kind of is in the form of that heat. So those are pretty connected there. But one thing I want to point out as far as the electronics, that first point, some things to keep in mind that we found to be more temperamental than most. Certain CPAPs, a lot of CPAPs, in fact, don't work well with modified sine wave inverters. Some of the motors on certain refrigerators depending on, again, more and more of the newer electronics don't work as well with the modified sine wave. They just have more sensitive internal components, and things generally, even if they work with modified sine, they last longer and operate more efficiently and at a higher level with the pure sine wave inverters. So some advantages: we have a higher efficiency, again, because of that smooth output. You don't have the resistance, you don't have the choppiness, you don't lose all that power. And again, pointing out some of these features that are some of these electronics that work particularly well: refrigerators, CPAPs, microwaves, really anything with kind of that mechanical motor. Microwaves are particularly finicky in some ways, and we're going to talk about those here in a little bit specifically. So hang tight for those. Those can definitely have caused some issues for drivers we've talked to in the past.
All righty. Thank you, Hall. That's a lot of very good information just to start it off. Some of the next things we can talk about is, again, like Hall started with, is what do you want to run? What do you need to run? Is this more of a vocational type application where you're only going to run one or two devices? Or is this, again, truly a sleeper application where you need to run everything to be comfortable? So this chart here gives you some examples of different loads, and some of them you have to be very careful with. One is we list refrigerator. There is a big difference between refrigerator and a cooler. An actual refrigerator has a compressor and will get food much cooler, versus just a cooler does not have a compressor, doesn't require as much load, not nearly as sensitive, needing pure sine versus modified sine. But one of the biggest ones that we get calls in for tech support and just fleets having issues is microwave ovens. Microwave ovens are always sold based on their cooking wattage, not power consumption wattage. So someone buys a 700 watt microwave, well, that's 700 cooking watts. Power consumption may be as much as double that, or even worse. And it's like everything else. We talk about efficiency, whether we're talking about the microwave or talking about the inverter itself, depends on the quality of the electronics and how well it's made. That if you buy a microwave, based totally on price, I can guarantee it's not going to be nearly as efficient. It's going to pull a lot more current. So we get calls says, well, it's only an 800 watt microwave. Why is the inverter tripping off? Because it's actually pulling a lot more current than you realize, and it's shutting down, doing exactly what it's supposed to protect itself. But if you look at all these, again, different examples, one thing to always keep in mind: anything that makes heat pulls a lot of current. Good example is, you buy a hair dryer, they're rated at watts. It makes heat. So same thing, coffee maker, microwave, air fryer, anything, again, that makes electric heat is going to pull a lot of current. Thankfully, most of the time, those are not devices that we run very long. But if you've got a refrigerator that's running and you try to make coffee at the same time, there's a good chance it's going to shut down simply because you've overloaded that inverter. And going back to quality and efficiency of inverters too, is you have to be very careful what you're buying. The economy unit is not going to be nearly as efficient. It's not going to be able to put out maybe the full rated wattage. Seen some inverters that will claim that they're a 1200 watt inverter. Well, 5 minutes in, they heat up and they derate, and they may only be an 800 watt inverter. So you have to be very careful what you're buying. Just because it says 1,000 watts or 1,500 watts or whatever may not be the same. Same thing too is looking at surge capacity. Again, anything's got a motor is going to have somewhat of an inrush current. Same thing, you got a skill saw. When you first kick it up, notice the light that's on the same circuit at your house will dim, because when it first starts up, it pulls a lot more current. So you have to make sure you got an inverter that can handle those surges as well. A good inverter is typically going to be double whatever the wattage rating. So if it's a 1,500 watt inverter, generally they'll take 3,000 watt, as long as they are accurately labeled. But again, you got to look at all these. What am I trying to do? Some of these I may run at the same time. So you need to add them up and say, hey, can I run all these things with a 1,000 watt or 1,500 watt, 2,000 watt, whatever. We also see people have a tendency to want to over spec inverters, simply because they've been buying an inferior product that does derate like we were talking about. And so in order to get the 1,500 watts they need, they wind up buying a 2,000 or even bigger. I've seen some fleets that buy a 3,000. That is a good way to have jump starts and all kinds of other problems because of the amount of current that you could be pulling out of the batteries, which we're going to talk about that on the next slide. Is whenever we do these calculations, we got Ohm's law we can use, that watts equals volts times amps. So you can divide it the other direction, as amps is going to be your watts divided by the voltage. That, again, you have to understand what you're pulling out of the DC batteries in order to make that AC power. That there's no such thing as free lunch on any of these. That a 110 outlet in the sleeper of a truck is not the same thing as being plugged into an outlet in your house or the hotel. That you are pulling from a limited power supply here. Example again of that 1,300 watts. It's actually only a 700 watt cooking wattage, but 1,300 watts divided by 110, you're pulling 11.8 amps AC out of it. But that same 11.8 amps AC is equivalent to 108 amps out of the batteries. And where that gets important is when you look at capacity of batteries. You can look at your amps times time and figure ampere hours. And it doesn't matter what the load is. If it's on for an hour, for example, first one here is you have 10 amp load, it's on for 1 hour, you've pulled 10 ampere hours out of those batteries. If it's a 50 amp load, it's only on for half hour, you've pulled 25 ampere hours out of those batteries. What does all that mean? Typical truck, you're going to have 4 group 31 batteries. Each one's going to have approximately 100 ampere hours of energy. Now, 100 ampere hours of energy if the battery is new and at 100% state of charge. As batteries age, they're going to have less capacity. And also, if you only start off at 90% state of charge, now you're only going to have 360 ampere hours of energy total. So you do have a limited bucket there, so you do have to make sure what you're pulling out of those batteries. Again, inverter loads. Most things are going to operate fine on a modified sign. There are some things, again, like Hall was saying, is microwaves are one that some microwaves will not even turn on if you try them. In fact, I did some research, on their website, says it will not run off those. We've tried to do a lot of research over the years, especially, again, like Hall was talking about, CPAP machines. Most of them do require a pure sign, but we only found that out from trial and error. We talked to a lot of the CPAP manufacturers, and they couldn't even tell us. And if you look at the number of CPAPs that are in the trucking industry, that's pretty important information they need to be able to tell somebody, and they couldn't. So we got samples from different people and worked with drivers and, hey, let me borrow your CPAP for a minute, see if it runs on this or not. And a lot of them don't. Other things you have to be very careful of is anything that has a battery internal, such as using a laptop. That brick that's in your laptop power cord, that is a regulator. It steps it down from 110 to 10 volts, 18 volts, whatever your laptop charges off of. That modified wave can mess with the regulation that's within that power supply, and it's not going to ruin your laptop next week, but it is definitely going to shorten the battery life of it. The other things we found is things that have like a microwave that's got a digital clock on it. A lot of them use the AC, the hertz in it, that the waveform to basically power the clock. And because it does not get a clean signal, the microwave clock's always off. So just some weird things you may not be aware of. But again, some devices do not like modified, and some devices will not work on it, period. In high surge loads, again, anything that's got that motor that Hall was talking about, that can be a compressor, it can be a cooling fan, power tools, because we see everything in a sleeper. So again, anything that has those is going to have a bigger inrush. Even microwaves have an inrush compared to operating. So one thing, if you have problems with your microwave, adjust the power level from a 10 down to 8 or whatever, and it may work fine because, again, less cooking wattage, so it's going to pull less. Again, timeout function is, again, that surge. Again, inverters can handle a surge bigger than what they're rated at, but depending upon how big the surge is and how long it is going to determine if that inverter is going to be able to power it or it's going to shut down and protect itself. One of the other things very important here is low voltage protection. Again, we talk about you have a power supply with a limited amount of energy that you want to make sure that you're happy and comfortable, but also you don't want to cause yourself short battery life or possibility of a jump start. So you always want to make sure you have an inverter that has true low voltage protection. A lot of inverters out of the box are really designed for a different industry, where you have totally different battery banks, where you have cranking batteries and house batteries, where you can really cycle those auxiliary batteries much lower. With a typical truck, you don't have that, so you do want to make sure there's something there to protect it. Our general rule of thumb is around the 12.2 volt range. That's going to give you enough runtime without running the engine and not overly cycle the batteries. And then there's more to it than just a hard set limit too, is there's a lot of logic that goes in to make sure that it's not going to shut off just because of engine crank, things like that. So there is a lot more than just a box saying it has low voltage protection. All right, we're going to do one poll question, and Hall's going to have another one for you too, but I'll do the first one. Which inverter is best for medical devices? I have two options here. First one is pure sine, and the second one is modified sine. That if you hit that the little circle next to whichever one, it should highlight with a little dot in the center, and what you do, hit the submit button. Give everybody a couple seconds to do it. All righty, everybody got it right. Yes, pure sine is what you always want to run for medical devices. One is medical device. You want to make sure that thing's working properly to protect you, and again for CPAP, make sure you're getting a good night's rest. And I'll let Hall do the next one.
All righty. So the next question is: a microwave will only draw in watts what it is rating for in cooking wattage. It's just a true/false question. How much wattage is that microwave going to pull? Just another few seconds. See some responses coming in. About 10 more seconds. Microwave will only draw in watts what it is rated for in cooking wattage. True or false? All right. Let's see what we got. False. Correct. So cooking wattage obviously is what it is rated for, but like we talked about before, with microwaves being inefficient or with surge ratings, different things, we expect that wattage that it actually draws to be higher than what that cooking wattage is. So definitely something we want to watch out for and want to account for when you're selecting your inverter.
Now, one thing very careful out there is we see people buy an economy inverter and an economy microwave, and for some reason, hardly anything works.
Yep. Definitely got to make sure your thing's going to work well together. Cool. So we've talked about generally what an inverter is. We talked about a few key things to selecting an inverter and what to look for and how to calculate that. So you've got your inverter now. What do we need to think about when we're installing this inverter? And as we're going through this, just want a reminder, like Celia, we mentioned at the beginning of this, that there are some added features on this webinar, and these are also online. One of those things is a video showing and walking through an installation of an inverter. Obviously, that inverter is one of the Purkeys inverters, but generally the steps and the questions to be asking and the things to be looking for are universal when you're installing these things. So it's out there if that's helpful to look at. So first thing to look, or excuse me, a few things we're going to talk about here. When you're installing the inverter, you want to look at cables. What size and length cable do you need to install your inverter to make sure it works well, that it's getting the power it needs to, reduce resistance, reduce voltage drop. What kind of circuit protection is in place? This is going to be really important. Obviously, if there is an issue, you want to make sure everything is protected so there's not any kind of thermal event or not having to replace cables. Hopefully, we'll just have to replace a fuse or fix a breaker. Placement, where is this inverter need to go? And kind of what are the parameters around that? Choosing an installer. Do you want this done aftermarket, OEM, and how do you kind of select that installer? And a few other points to note when you're looking at this. So first thing to note is on the cable sizes. This just kind of gives a general overview of cable sizes. So it starts small cables of 18 gauge, and then we go all the way up to 4/0 cables. So as we're talking about that, just for all the cable newbies out there, this is kind of what this might look like. This isn't exactly the scale, but 18 gauge is smallest, 4 gauge would be the largest. So we have a chart here and kind of a sample calculation to talk through how we go about calculating this. So like Larry mentioned earlier, when we're calculating the wattage and the output for our inverter, the calculation we use is watts divided by volts equals amps. And amps is what we're going to use to determine what size cable you need on your inverter. So just a demo calculation, let's say we have a 1500 watt inverter. We're going to divide that by 10 volts. I know this is a 12 volt system, but we use 10 generally because that will give us added size. It'll account for more amps in case there is inefficiency or resistance or anything, or just low batteries or anything comes into play. We want to make sure we're sized for sort of that worst case scenario so that we have enough cable to do what we need to do. So doing this calculation, watts divided by volts, we have 1500 watts divided by 10 volts gives us 150 amps. So this 150 amps is what we're going to think about and use when we're sizing this inverter harness. So here on this chart, we have amperage on the left axis and length of cable on the top. Generally, inverter harnesses are, 8 to 16 feet, really. I think most of the ones we sell are generally 10 to 12, but it depends a lot on where your inverter is going to be relative to your batteries, how you're going to run those cables to make sure that they're secure and do not rub on anything. So we have to work with both of these things because the longer the cable is, the more prevalent voltage drop is going to be. So as your cables get longer, you're going to have to size them up. So as you can see here on this left side at 2 feet, we have some very small cable. For example, if it's 10 amps, we have a 16 gauge cable. As the cable gets longer, up to 50 feet, we're going to go to a 6 gauge cable. So with this, we're looking at 150 amps, which is right here between 160 and 140. Like we mentioned before, we're thinking worst case, so lean more toward the 160 than the 140 on this. And then you want to look at the length. So let's say we have a 10-foot harness that we need here. So you follow that down at 160 amps. we're looking at 2-gauge cable. Now, at Purkeys, we build all of our cables at 1/0. Make sure that these are larger cables, just to really ensure that there's enough cable there to get the power through, that we reduce resistance enough, we reduce voltage drop as much as possible, because we want to make sure that the optimal power gets to your inverter. And we also have, like Larry mentioned, if your inverter has a low voltage disconnect, you want to make sure it's reading an accurate voltage reading from your batteries so that it doesn't have to shut off early. If your batteries are at 12.5 volts, but your inverter is reading at 12.2 volts because you've got a whole bunch of voltage drop, then your inverter is going to cut out way before it really has to. So you want to make sure that that cable is sized right, that the length is really as short as you can. But if it is longer, that you have the larger cable. So definitely something to think about as you're installing your inverter, or talking to your installer about what they're going to be using. The second piece of this is circuit protection. So here we have 3 different modes of circuit protection that you could use. We have a large mega fuse, we have a fuse cube here in the middle, and we have a circuit breaker here on the right. So all of these will work as circuit protection. Typically, well, not typically, on all of our harnesses at Purkeys, and what we always recommend to people, whether you're using our harness or not, is that you use some sort of fuse cube similar to what you see here in the middle. And there's a couple of reasons for that. The first is, since this fuse cube is actually, and in one of the earlier pictures we showed that there was the harness from the inverter was going to the battery and the fuse was right there. So since this fuse cube sits on the terminal of the battery, it protects 100% of the inverter harness. So if there is an issue, all of that harness is protected. All you have to do is replace this fuse. Whereas if you have an inline fuse, similar to what we see here on the left, there is going to be some portion of cable that is going to be damaged that will go between this fuse and the batteries. So you'll always have kind of that exposure and that cable to replace, rather than just popping in a new fuse and going about your day. So you might ask, well, a circuit breaker seems even simpler than that. You just reset it and you're done. While that's true, we always like to mention that if your circuit protection blows for whatever reason, whether it's a breaker or a fuse, there's a reason that happened. And if you just continue to reset a breaker because it's so easy, you don't really think about it, that could continue to build resistance. And even though you have this breaker in place, it could still lead to a thermal event, just due to heat buildup over a short period of time, because maybe you've got a bad ground or bad connection somewhere, something's happening and you're pulling too much power through those cables. So we always like to recommend the fuse cube. It offers complete protection of the harness, and is a little bit more difficult, I would say, than the circuit protector or than the circuit breaker, to make sure that you're actually disconnecting these things, taking a little time instead of just resetting a breaker over and over. So just something to think about as you're setting these up. Another thing to notice is that on this inline fuse, for example, and on this breaker, these do have mounting holes here. They're designed and prepared to be mounted in the battery box on that wall. A lot of times we'll see fleets, drivers, installers, whoever put these on, not mounting these to the actual wall, and so they're kind of floating around. This can cause for loose connections. This can cause damage. We definitely recommend actually securing these to the wall of the battery box if you're going to use one of these two. Obviously, with the fuse cube, it's going to be connected right there at the terminal, so you don't have to worry about that. But just something to keep in mind as you're installing. Make sure everything is secured down well. And I'll turn it over to Larry for this next section.
All righty. Next time we're talking about just a little bit of, who and where. Again, if you're buying a new truck, there are options available to have it done actually as the truck's being built. There are options doing them at a PDI center. You may have your local dealership do them. You just want to make sure that some of the things we talked about, make sure they follow. Because when you have cable this big and something bad happens, it quickly leads to a thermal event. So you got to make sure that they are using the right size cable. We've seen all kinds of aftermath of poor quality installations. Again, whether it's undersized cable or the wrong type of cable. And we don't want to spend an hour talking about wire and cable, but there is a lot to go into selecting the right type of cable. There is SAE specs for all that, for what kind of temperature can it handle, what kind of abrasion resistance it has, chemical resistance. That's seen cables where all the insulation fell off a year into service. So those are all things you got to be careful about. You want to make sure you have a quality installer doing it. So use the information you gain from this to go if you are going to find an independent to do it. And again, go through and figure out the right place to mount it. Airflow is very important. It has to be able to cool down. Most inverters, I'm not going to say all, but most do have some sort of thermal protection that if they get too hot, they will shut down and protect themselves. That's not a guarantee it's going to work. So you want to make sure that you do your part to put it somewhere so it can get covered with clothes or get chains sewn across it. Again, most harnesses and most inverters have some sort of covers for the connections, but those can fall off, get damaged, whatever. So you do have to make sure that all those things are right. So again, it can be anywhere from OEM built on the assembly line, as a spec item. It can be done at pre-delivery or post-delivery inspection type installer, dealership, you name it. There's many options for you. They're not saying you can't do it yourself. Just again, you got to follow these things. And one of the other big ones too is damage and spills. We get inverters sent in that people want warranty, and it's like, yeah, it can't be full of soda and dog hair, and expect it to live. So warranty rejected. Which kind of brings us to one of our next slides, is making sure you give that inverter a good, safe, happy home. Some of the things we talked about before is like microwaves. Some of these high load devices. If it's pulling 150 amps out of your batteries while you're cooking dinner or whatever, you may want to start the truck. Because one, you're going to take a lot of energy out of the batteries, and that's again why we kind of limit how big of inverters we would ever recommend on a typical truck. Because again, you do have that limited battery pack. It's only so big. So if you do run a bigger inverter, yes, it may run it, but now you're cycling batteries harder. You're going to impact battery life, run the risk of jump starts, etc. But if it is a high load device, whatever, yeah, run the truck for that 5 minutes while you're hooking up or cooking dinner or something. If low voltage, seems to be a common problem, you may again look at what are you running. Again, can be simply as efficiency of the product you have. You could be an issue if it's based on how you're operating. I am sitting a lot longer than a normal truck would. I've got customers that do wind turbines and stuff. Driver may deliver load there, and he's stuck for 3 days because of wind or whatever. So he's going to use his inverter a lot more, and he can either idle the engine, or if he wants to save fuel, he wants to get as much runtime as he can. So he may have to look at adding batteries, a separate battery bank, maybe changing the type of batteries he has. Or it could be a deal that says, hey, it's telling you that those batteries have lost capacity. And there's other things that are coming into the market now, such as lithium batteries. So there is many things you can look at, depending upon how you're operating, what you're doing, that you may want to take a look at to get the best life you can. And some other things is routine maintenance. That we took the cover off this one just to show it, but that inverter's been ingesting hair for months, and if it hasn't already failed, it's going to. So if you are dusty environment, You are traveling with a pet. You may take a blowgun, blow it out every now and then. There is nothing serviceable inside of an inverter, so we don't ever recommend you opening it up. But at least blow it out. Make sure you're not getting a bunch of foreign debris in there. Cooling is key on it. That whether it's stuff up against it or stuff inside of it, if it can't cool, it's not going to have a happy life. In troubleshooting, we're going to split this up. But one of the first things with any inverter, the first thing you can do, whether it's a fleet truck or your own truck, that inverters have many different shutdown protections. Again, low voltage, over temperature, over current, under voltage, all these things. The first thing we always recommend to do first is unplug all your devices, start the truck, make sure those batteries have a chance to recover, and shut the inverter off and back on. That will take care of most issues. One exception is if it is a temperature one, make sure it's uncovered and give it a chance to cool down. But most faults we're going to fall under one of those. It's over temperature, overloaded something. So just give it a minute and let it reset. If it's more in depth than that, but before we do that, we got a quick question for you. What is the suggested way to restart an inverter? First one is restart the truck. Second option is restart the truck and turn the inverter off and on. Third option is disconnect the batteries. Or fourth one is there's no way to reset the inverter. So I'll give you all a couple minutes to, or maybe not a couple minutes, but at least several seconds to answer. Let's see, we got a couple have answered so far. Again, just highlight the center of whichever circle and hit submit. And let's see what we got. And yes, 100% got it right. Restart the truck, turn the unit off and back on. Again, turning the unit off and back on is very part of it. First one was just restart the truck. Disconnecting the batteries, that can be a solution. Inverter basically is still a computer. Sometimes we have to shut our laptops off and turn them back on to get them to work right again. So you go through all those things, can't reset it, disconnect the power, let the inverter sit for a few minutes and reconnecting the power. Sometimes we'll fix it as well. Just depends what that fault is. Time, restart the truck, turn the inverter off and back on. I'm going to turn it back over to Hall again.
All right. Thanks, Larry. Oops. Went too far. So I'm going to take just a couple minutes here at the end. I'm not going to go in deep onto what each of these mean, but speaking of troubleshooting and error codes and whatnot, we just wanted to give a few examples of kind of the different ways that different inverters can present their troubleshooting information and how to interpret that, kind of where to look for whatnot for things, and also just the different levels of error codes essentially that can be had on an inverter. So we wanted to start with, we just pulled this from our the user guide of the Purkeys modified sine inverter, and essentially just want to show what this looks like. So for this inverter, it's a modified sine unit. It has some protections in place, but as you'll see for the next one, it doesn't have as many different diagnostic indicators as some other units. For example, here we have a fault light, which is number 4. It's right here. It indicates that power is shut down due to inverter overload or over temperature. So you don't get that exact pinpoint of what it is, but it's either overload or over temp. And then we have a power light saying that it's on and operating. So we do have a GFCI there. Some will or some won't. But just to kind of give you an intro, this is kind of what you'll see on quite a few inverters is just have kind of a light that shows, hey, there was a fault. This is sort of a known fault. I'm not sure exactly what it is, or we can't tell you exactly what it is, but it's due to one of these factors. So in that case, you can take a reading on what the outputs are. Maybe try unplugging something and plug it and try it again, or just let it rest for a little while if it seems like it's a little warm. For other inverters, there are going to be more faults. So this more fault codes rather. So this one again is just showing an LED. So this just shows low voltage disconnect LED, and we have a separate output fault LED or LED and an input fault LED. So again, this inverter just has lights, but it has different lights for specific occurrences. So it gives you a little bit more detail of, is the issue with the input, is the issue with the output, is the issue just for low voltage at the batteries. Kind of helps define that a little more. Then we have, this is another one of our inverters, just used as an example, but this one has a control panel, essentially a little remote that will mount somewhere, and it has these different lights on it. They typically show available battery percentage, how much time you have left to use your inverter, but they also indicate faults. Excuse me. So there is just a standard fault light showing kind of what the fault is from, and gives a little more indication as to where that fault may be occurring, what should be corrected in order to fix that. And then lastly, there is, actually might have one more after this, but I think this is the main thing, is other inverters that have a full LCD display rather, that can be mounted somewhere that will actually tell you what the fault is. So there's an error code E01 that will appear on this display that correlates exactly that to an error code within that unit. So a lot of this is, again, just like anything else, there's typically a higher cost if there's a whole separate panel with the LCD display. But just something to think about as you're purchasing your inverter is what level of diagnostic information is available to me from the inverter if there is an issue. How easy is it to correct these issues? What are all of the different failure modes that are actually illuminated by this diagnostic issue? Does it have an over-temp protection? Does it have over voltage protection? Does it have output overload protection? There are a lot of different things that it could have. Low battery voltage, which is one that we've talked about before, to make sure you're protecting those truck batteries. So definitely something to think about as you're going through your inverter. How well is it protected, and how easy is it for me to understand what's going wrong and to fix that if there is an issue. So with that, we've got one final question for you, and then we're going to open it up to Q&A. We'd love to hear from you. But first, if you wouldn't mind giving us a little bit of feedback here, would you recommend this information to other drivers? We're not going to share this at the end, this response. This is just purely for our internal use to see if this information was useful. There's also, with the Q&A section and just with some general feedback, we're always appreciative of that. Just trying to know if the information we're putting out there is helpful. So I'll just help the industry and help you guys, help drivers. So I want to make sure we're doing the right thing and presenting the information that's helpful. See some responses still coming in. I'm going to give a few more seconds. Let's get as many as we can here.
And once this is done, we're going to open up again for Q&A. Please don't anyone drop off, though, because after we do take any question and answer or questions that come in, there is some survey questions that we always like people to answer as we wrap up the webinar.
All right. So I think we're good on this one. We'll go on forward. And with that, open it up to some questions.
Say it's quiet today.
It is
if
quiet
anybody
today.
does have any, feel free to type it in the Q&A chat part there, or again, you can reach out to either Holler or myself afterwards. Our contact information is in the resources. That our job is to help you.
Yep.
All right. Don't look like we have any, so we're going to let the survey questions roll. And thank you all very much for joining us today.
Thank you, everybody.